Today we would like to model real-world situations with mathematical equations. You need to show a slight bit of patience here and just understand that I know that a lot of these problems you would not do in real life. We're trying to teach you how to model things so you could actually do the type of problems that would come up in real life. So I get you're not going to try to find 4 consecutive odd integers that add to 80, but this is part of a bigger piece of teaching you something that you could do. So let's begin. And let's start with some, well, how about this? Just talk with your peer, 15 seconds. What's an example of 4 consecutive odd integers? Talk, go.
3, 5, 3, 7,
5, 4, 3, 2, 1, and 0. Somebody give me an example of 4 consecutive odds.
3, 5, 7.
Good. And if you were to add those up, you get 8 plus 16 is 24, right? Now, it turns out that these add to 80. So something that I've noticed that kids, when we start this stuff, usually I just start right in with the problem and start working it out. But I notice a lot of people don't even understand what this idea means. 4 consecutive odd integers whose sum. That's what it means. If we were to take 4 odd integers that are in a row and add them up, we get 24. We want to know what 80 is. Now, some of you guys think you're really, really intelligent because you know what 17 and 19 and 21 and 23. Good for you. But we're going to give you problems that you can't just guess. You're going to have to model it with an equation, okay? So let's go ahead and model it and see how we come up with that. First, we need to start with the expression of consecutive, not numbers, but should say consecutive integers. And consecutive integers, yes, like 1, 2, 3, 4, so on and so forth. But I'm going to write as x. The next one would be x plus 1. The next one would be x plus 2. And then x plus 3. And so on and so forth. That's the algebraic representation for consecutive integers. You may know what we could do to a number to make it not just a consecutive integer, but even integers. Okay, I get what you're saying. So just to help you understand, suppose you had x plus 2, x plus 4, x plus 6. So if x was, say, 10, then notice you get 12, 14, and 16. See that? But the deal is if x wasn't 10, if x was 11, well, now they're all odd, aren't they? So these expressions don't always produce an even number. What would produce an even number? Multiply by 2. Yeah, if you multiply any integer by 2, it's going to become even. Would you agree? So 2x is an even integer. What would be the next one after that that's even? 2x plus 2 is going to be 2 units away because you got to skip the odd one. And then 2x plus 4, and then 2x plus 6. Odd integers, we just simply start with an even integer. What is something you can do to an even integer to then make it odd? Add 1 to it. And the consecutive one after that would be 2x plus 3, 2x plus 5, 2x plus 7. So I've laid those out for you. So when it says find 4 consecutive odd integers whose sum is 80, I'll take those consecutives, 2x plus 1, 2x plus 3, 2x plus 5, and 2x plus 7. And those all have to add to 80. So what are you going to do?
Hello everyone, very good evening. And I would like to welcome you all for the second day of the serial program. And I'm Leela from Excel Solutions. So yesterday I had given you
Did we go to McDonald's? What?
Let me guess.
No. Daisy gets hers first. Why does Stacy get hers first? It's just too fast.
Oh, good times. All right, sorry about that. All right, so let us combine like terms. How many x's do we have?
4.
Very good. 8 x's plus 16 is equal to 80. The actual algebra is very simple. We just subtract the 16. 8x is equal to 64. So x is 8, and that's my answer, right? No, that's not my answer at all. I told you the answer ahead of time. It's not 8. So let's look back at this solution up here, or the question. It says, find 4 consecutive odd integers. Notice that this is one of my odd integers. It's not 8, it's 2x plus 1. So 2 times 8 is 16 plus 1 is 17. So 17 is one of them. And then 2 times 8 is 16 plus 3 is 19. And you can see how you then produce the odd integers. So you must be able to go back to the problem, make sure that you've answered it. The x equals is not necessarily the answer, but allows you to find the answer. Understand? Okay, so let's look at the next one. This talks about the sum of 2 consecutive squares. I want you to just find any 2 consecutive squares and add them up. Take 20 seconds, talk, go.
9.
All right, and stop. Give me 2 consecutive squares. Okay, so 4 and 9. And if you add them, you get 13. This is talking about 2 consecutive squares that add to 613. So 4 and 9 are not the answers, right? But how do we write an equation for that?
Oh, x squared.
Like that? Let me show you why that's, what's that? Yes, so let's look at why that's incorrect and that's correct, okay? So what number did you square here to get 4? Squared 2. What number did you square there to get 9? 3. So isn't it x squared and then x plus 1, that quantity squared? Isn't that what's happening? See the difference? So therefore, it's not x squared plus 1, but rather x plus 1, that quantity squared, is equal to 613. So I have x squared plus what? Plus 2x plus 1 is equal to 613. Very good. X squared and x squared make 2x squared plus 2x plus 1 is 613. Now this is different because it is of the second degree. How do you solve something of second degree? Factor or? Either way you should set it equal to 0. So 2x squared plus 2x minus 612 is equal to 0. And right now you're kind of happy because you're like, oh yay, it factors because I can take out a 2. But after that you're like, oh, that's still a big number. 2 times x squared plus x minus 306 is equal to 0. So if you don't want to factor it, you would have to use the quadratic formula, or you could say, well, my wonderful teacher, Mr. Gans, see, one day he sat down and showed us on our calculator how to type that into our programs. Did I not? PRGM.
Oh, we made it.
I go down, I press enter on quad 2. And I press enter. It's fine if you have just quad 1. I've made the same program twice, so don't worry about it. So A1 is going to be, or A is just 1 because that's what's in front of the x squared. And then B is positive 1 as well. And then C is negative 306. And you can see that you get 17 and 8, negative 18. Yeah, or to which part? Okay, so I press program, and you just press enter on whichever one you want to use, and press enter on that. And then just enter A, B, and C. Okay. So what do you guys think? Do you think that 17 works, or negative 18, or both, or neither? What do you think? No, you got one answer? Then you're missing part of your quadratic formula. We're going to have to change that. So let's check, okay? And this is the moment where you want to get a little bit curious because this is actually really, really cool to see how this works out. I think we would be all inclined to say that 17 would be what you use, right? So let's plug in 17. What is 17 squared? Good, 289. And then if you take 17 and plug it in here, 17 plus 1 is 18, and 18 squared is 324. And those add to 613. Watch what happens if we plug in negative 18. What is negative 18 squared? 324. And what is negative 18 plus 1? Negative 17 squared is 289. Isn't that interesting? The mathematics does this amazing thing where it says, hey, not only am I going to show you the two squares, but I'll show you two ways to get it, and you could have either one come first. You know what I mean? Like, it is pretty impressive how math does that. So, all right, flip it over. Yes, and we did. We got 289 and 324. Those are our two consecutive squares. Okay? A rectangular garden has perimeter of 288. Length is 4 more than twice the width. What are the dimensions? See if you can draw the picture and put in some labels. Go. Okay, I hope I see a rectangle drawn. If we don't, there's probably a problem there. And I do have width, and I do have length. Now, the part that I would really like to see you write down is the second part, which says if the length is 4 more than twice the width. And this is a piece that you're going to have to try and interpret. Length is 4 more than twice the width. So I can say 4 plus 2w for that. See that? Sure, that's fine. But no matter what you're going to have to do is you're going to have to come up with an expression for perimeter. And perimeter is the sum of all the sides, right? And we know that it adds up to 288. So that would be w plus w, or if you chose x, you'd have x plus x. And then I'm going to add the top and the bottom. So I'll do a 4 plus 2w and a 4 plus 2w. Everybody clear how I came up with that? Any problems with that? Okay, so 288 is equal to how many w's? 6 of the w's plus 8. And that should be enough for us to be able to solve. We simply subtract the 8. 280 is equal to 6w. And we divide both sides by 6. W is equal to, how about we do it exactly? 40 what? 46.6 repeating. Is that the answer? The question asks for the dimensions. I have the width. The width is 46 2/3. I now need the length. So I will plug it in to find the length. Nice and easy to find the length. I just take 4. And I add that to 2 times 46.6 repeating. And notice how you get 97.3 repeating. And those are the dimensions. We good? Yes, hi. Oh. Good boy. Okay. The next one is a classic problem. It gets used in calculus, this one you're going to need to watch me as I do this, and this is something that does get used. Anyway, and they tell us in this situation that the volume is 100. Okay, a box with a square base and no top is to be made from a single piece of cardboard. So I'm going to draw the piece of cardboard. And as we have this piece of cardboard, we are going to, we're going to cut a corner here, and a corner there, corner here, and corner there. And does it say what size of corner that we should cut? Yeah, we're going to cut 4 inches. So 4 and 4, 4 and 4, 4 and 4, 4 and 4. So suppose that this box right here has or this piece of cardboard has a dimension of x, and then this also has a dimension of x because it says it makes a square base. So if I draw the box that it actually makes, I know you're going to be really impressed by my drawing here. I've got a box. Can somebody tell me what's the base going to be? Is this base going to be longer than x, shorter than x, or the same length as x? Shorter by how much? 8 less than, right? So it's going to be x minus 8. And how about this side here? X minus 8. And then what about the height? Folks, we fold up the side. Isn't the side that we fold up is going to be 4 units, whatever we cut out? Okay, look at my thing, okay? See, I made the shape. If I cut out a 4 by 4, then when I tilt it up, it has a height of 4. Whatever your cut was, that's what the height is. So we know that the volume is 100. And the way we calculate volume is we multiply all 3 of these dimensions together. Or 4 times x minus 8 quantity squared. How are we going to solve this? Let's divide both sides by 4. So 25 is x minus 8 quantity squared. What do you then want to do to solve it? Square root. I get plus or minus 5 is equal to x minus 8. And then what do we want to do to both sides? So we get 8 plus or minus 5. What's 8 plus 5? 13. What's 8 minus 5? 3. Do you think one works, both works, neither one works? What do you think? Only 13. Why? Yeah, look what happens. If you start with a 13, then 13 minus 8 is 5, right? 13 minus 8 is 5. But if you use 3, 3 minus 8 is negative 5. You have a negative dimension. Mathematics can. Mathematics isn't worried about negative dimensions. We are, because we exist in this weird real world. So a 13 by 13 is what we want. Okay. All right. It is time for me to hand to your homework. I've got 1 minute to get that to you. Does anybody see the homework packets?
Problems 1 through